for my fellow trekkers out there. So in thinking of tools of the trade, you probably think more of telescopes. You can imagine if this really was the way astronomers had to count the stars. We're going to look at these first two types of telescopes on the page here. First one, refracting. Your refracting telescopes are basically made up of two lenses, one near the eyepiece and one near what we call the objective. These arrows are representing light coming in. Refracting telescopes, not so much in common use today. They're more ornamental pieces or for die-hard astronomers. The refracting telescope dates back to the 17th century, 1600s, with its perfecter of Galileo, on a first-name basis. He is from Italy. He didn't actually invent the telescope, he perfected it. And the 400th anniversary of his perfecting the refracting telescope was declared the International Year of Astronomy. And one of the things they did was mass produce a plastic rendering of the Galileo telescope and the Google Doodle in honor of the ornamental way in which his original refracting telescope looked. And ever since the 17th century, we have definitely increased our vision capabilities through this marvelous technological device. The Italian Lipare is the gentleman often associated with inventing the telescope. Remember, Galileo perfected the refracting telescope. Sir Isaac Newton from the United Kingdom, specifically England within the UK, he perfected, again, didn't invent, but he perfected the reflecting telescope, which also has a lens. The different components you have in the reflecting telescope that make it different than the refracting, of course, would be the mirrors. The thing you want to concern yourself with when purchasing a reflecting telescope isn't the advertisement of this will magnify things 10 times, 100 times greater. You can change out these eyepieces for magnification purposes. If you do invest in a reflecting telescope, you want to look at the size of this base mirror. And it is definitely one of those situations that the price increases as the size diameter of this mirror increases. The mirrors allow for the light to enter through the telescope, so they tend to look like, big cannons with openings here to allow the light, and then it gets concentrated to the smaller mirror reflected to your eye. The way to kind of think about how a telescope works is, a reflecting telescope, is the more light that you're able to get, the better concentration, and the better concentration, the more crisper the image is going to be. Just like if you have a little trickle of water, not so great of a stream, but lots of water or light entering your scope is going to provide for better images. So side-by-side comparison, the reflecting telescope, they tend to be larger in barrel size because they are housing the large diameter mirrors. The size cost, usually I say don't get anything smaller than a 5-inch telescope. If you go into the piggy banks, a 5-inch telescope probably can cost you somewhere about $300. I have friends in astronomy clubs that have invested an enormous amount of money over an enormous amount of time that they saved for reflecting telescopes that are 20, 21 inches, and you're talking 4 digits for the price of those telescopes. The refracting telescope, it's very similar to what you might get at the dollar store in the sense of it makes things just a little bit bigger. And this is certainly what Galileo used to discover things such as the phases of Venus, craters on the moon in greater detail than what we would see from Earth of the craters of the moon. So we're not saying that these aren't wonderful devices. It's just now more modern times we go to the reflecting telescopes. If you are considering making a purchase to look closer at the night sky, or even objects in the daytime, I would encourage you to not actually purchase a telescope first, but start with binoculars. Binoculars are much easier to adapt to in the sense of a telescope you can sit on the ground. Remember that the Earth rotates underneath the night sky, and so once you get an object, say maybe the Moon, Saturn, Jupiter, into your scope, you only have a couple minutes before it's going to get out of the field of vision of the telescope. So by the time you run in the house, grab a friend to say, hey, look how great Saturn's looking in my telescope, it will have moved out of the field of vision. There are motors that you can buy for telescopes to account for this, but I find them a little bit glitchy. The thing I like about binoculars is that they're much more affordable, user-friendly, and that they're simply point and shoot. You want to look at that star and look in that direction, focus ever so slightly, and you can get a good glimpse into the night sky. I recommend getting binoculars that are a minimum of what would say 10 by 50 on the packaging. The 10 refers to 10 millimeters across, obviously not to scale here, and 50 millimeters across on the objective, so your eyepiece objective down here. And these will usually range, a good pair, maybe $35, maybe a special or coupons. You can get a little less than that, so definitely much more affordable than telescope. If you find that you enjoy looking at the stars, looking just ever so slightly larger through scopes, then maybe go for slightly larger power of the binoculars, or move up to a full-fledged reflecting telescope. Perhaps in your lifetime you may experience these. Scientists have developed the first telescopic contact lens. This lens is capable of zooming your vision to 3 times. This means that now you will be able to see Moon's surface and other heavenly bodies in the solar system by wearing it. Would you wear those?